Panchami Padkay is a market research analyst at TechInsights. Her focus is test connectivity reports, such as their probe card report, their socket report, and their device interface boards. And she focuses on the market analysis of semiconductor test, both in memory and non-memory markets. She has a bachelor's in mathematics and an MBA in finance. So, welcome, Panchami.
Thank you, Ira. Hi, everyone. Good morning or good evening. First of all, let me thank you all for attending the conference. And I also thank TestConX for this amazing opportunity. My name is Panchami, and I am a market research analyst at TechInsights. Formerly known as VLSI Research, TechInsights is the world's most trusted source of actionable in-depth intelligence related to semiconductor and market analysis. The focus of my presentation will be cost of test and its impact on test connectivity systems, which includes probe cards, test sockets, burn-in sockets, and device interface boards. Let me give you a brief overview of the presentation. Initially, I will start with some major concerns the world economy is facing right now, then go on to the introduction to test connectivity systems. Later, talk about test market and its forecast. Next, I'll be talking about cost of test, then briefly describe total cost of test, and finally go on to the memory and non-memory side of cost of test. Okay, economic environment. Let's talk about some concerns our economy is facing, which are especially affecting the semiconductor industry. I'm sure you would have heard the word inflation a million times, as it's not only becoming a major concern in the United States, but with the rest of the world as well. The Federal Reserve is trying to combat this 40-year high inflation aggressively by constantly increasing the interest rates in order to cool the economy and reduce the supply of money in the economy. There has also been a lot of disruptions in supply chain and production due to China's zero-tolerance COVID policy, even with very small outbreaks. And it has caused a lot of trade and supply chain issues about reliability and security with the rest of the world. Unfortunately, the war in Ukraine is not helping as well. Russia has choked off the supply of natural gas, which might result in energy shortage in short term. And redirecting resources away from growth-driving industries is definitely going to be a problem in the long term. And also, the US government has imposed significant new export controls on semiconductor and semiconductor manufacturing equipment transactions with China and Chinese entities. And these are affecting the advanced IC and related equipments as well. Okay, let's get into test connectivity systems. TCS, or test connectivity systems, are the products that enable electrical connection to be made between the tester and the device being tested. And this includes probe cards, sockets, both test and burn-in sockets, and device interface boards. First, we have the probe card. The chart I have on the left represents the total probe card revenue from 2015 to 2021 and the forecast from 22 to 2027. The data is segmented into different applications of probe card, such as epoxy, cantilever, vertical probe card, MEMS probe card, and other advanced probe cards. And on the right, we have memory and non-memory revenue trend of probe cards from 2015 to 2027. As you can see, there is a slight dip in the revenue forecast for the year 2023, and followed by a gradual growth until 2027. So according to our analysis, this confirms that the probe cards generally follow the total semiconductor market. Okay, and now we come to test and burn-in sockets. The graph I have on the left is a representation of test and burn-in sockets revenues from 2015 to 2027, including the forecast. The revenue of test socket was about 550 million US dollars in 2015, as you can see here. And if you look at 2021, the revenue rose to $1.4 billion, which is actually 118% growth. But as per our analysis, we forecast 2023 to be a tough year, where you can see a slight dip in the revenue. The chart on the right shows memory and non-memory socket revenue trend. Again, there is a close connection between sockets and overall semiconductor market. The device interface boards. The board market consists of two sides, the device manufacturing companies and interface board designing companies. Similar to the previous two slides, the chart on the left gives you an idea about device interface board market revenues, and the chart on the right talks about the revenue of memory and non-memory interface boards. Among the three aspects of test connectivity system, probe cards are the major player in the industry. And it's expected to grow to 3.5 billion by 2027. As you can see in the chart, the first one is probe card. The cumulative annual growth rate of probe card market from 2015 to 2027 was about 13.7%, with an year-over-year growth of 19% from 2020 to 2021, which was amazing. Our revenue forecast for the year 22 to 2023 is about 0.6%, which is definitely not great, but the markets are set to come back from 2024 onwards, and we expect the market to grow at an average rate of 6.5% until 2027. Moving on, let's get in detail about the test market. The test market can be divided into three main categories: automated test equipment, probers and handlers, and test connectivity systems. Memory AT, SoC AT, and other AT together make up for 6 billion of the test market, whereas handlers and probers make up to 2.8 billion, and the rest is test connectivity systems. The test hardware market grew from 6.5 billion in 2015 to 13.6 billion in 2021, as you can see in the chart, with a cumulative average growth rate of 8.9%. We forecast the market to have a CAGR of 5% from 2022 to 2027. Okay. Now let's see the short and long-term growth of the segments of the test market that we just discussed. As I already told you, probe cards, test and burn-in sockets, and interface boards follow the semiconductor market, and we can expect a downgrade in 2023. The long-term socket growth of 6% is mainly driven by non-memory socket market. And the long-term probe card growth of 18% up to 2027 is majorly driven by MEMS probe card and the non-memory side of the market. We can expect strong growth of logic AT market, whereas a slower growth of memory AT market. Let me talk about the connection between test market and the IC units, which will lay a foundation for my presentation. The blue curve in the chart represents the number of semiconductor units sold in billion units from first quarter of 2016 to fourth quarter of 2022. The red plot defines, the red curve shows the test and related equipment sales from 2016 to 2022. Now, the overall demand for test equipment is trending low from its peak at the second quarter of 2021. From our analysis, the probers and handlers follow the overall industry trends of the test market. So currently, the sales of test and related equipment are a little higher than the demand for IC. And this plot lays a good correlation and foundation for our cost of test analysis. Okay, as ICs get more and more powerful to meet consumer demand and the advancement that's happening, semiconductor device manufacturers are faced with one of the toughest challenges. How do we continue to drive down the costs of these new chips when each new version becomes more complex to test and requires increasingly powerful testers? Well, let's get to know about that a little. Here is a graph showing the historical data of the amount of money spent on testing each IC unit over a period of 42 years. The y-axis is the AT and handler prober depreciation capital cost per IC unit, which is calculated with a depreciation of 3 years, and it's in US dollars. The cost peaked its highest in the year 1996 and again in 2001, but has been trending low since then. This is the equation that I used to calculate the cost of test. So we calculate the depreciation of AT and handler prober total, and then add it to the total revenue of probe card, sockets, and interface boards. When we then divide this whole sum by the total number of IC units, and we get the cost of test. Okay, considering the equation from the previous slide, by including all three categories, AT, handler prober, and test connectivity systems, this is the chart which represents cost of testing each IC unit in the overall test market from the year 2000 to 2022. Here, I'm breaking down the cost of test into memory and non-memory market for better understanding. Looking at the historical data, the memory trend of cost of test of AT and handler prober market was at its highest in 2005. And the cost reduced substantially until 2010 and has been relatively moderate until now. And looking at the memory trend of cost of test for test connectivity devices, it has seen its share of ups and downs from 2003 to 2009, and it has been pretty stable since then. Similarly, this is the analysis for non-memory. The left side plot shows the cost of test for non-memory in AT and handler prober market, and the chart on right is for cost of test connectivity devices. Okay, this is the comparison of cost of test of both markets side by side for a clear view. And the blue curve is the cost of test of probe card, socket, and device interface boards. The orange is the cost of test of AT, handler, and probers. As you can see, the overall cost of test of using test connectivity is less than the cost of using AT, handlers, and probers. To conclude, the cost of test connectivity systems are about 2/3 of AT, handlers, and probers combined. As we looked at the charts from the previous slides, there is a significant difference between memory and non-memory testing. Since 2017, there has been a slight uptick in the cost of test for both memory and non-memory. Considering the cost trends in the industry, the cost of test reflects that the growth was between 2 to 4% every year since 2017. Finally, some of the biggest challenges facing providers of semiconductor test products have remained for decades, such as cost of test, improving the quality of the test program, and not impeding the productivity of designers. This will remain a key obstacle to overcome. But anyway, to reassure the test market suppliers, the test connectivity systems have not impacted in the growth of cost of test. This is all I have from my side. Thank you so much for listening, and thank you, TestConX, for this opportunity.
Okay. Great. Thank you, Panchami. A few questions. One from the audience. You want to leave your slides up, but or
yeah, sure. I can share again.
In case you want to reference any of them. So while you're doing that, why was there a rapid growth in the device interface board, which I assume also grew the top line of the test connectivity systems in 2020? Why historically the growth was significantly lower?
Well, test connectivity follows the overall semiconductor market thoroughly, and I feel maybe strong demand and higher ASPs. And because of the chip shortage scenario, we definitely had significant revenue growth in 2021. But also, we added a couple of new companies to our analysis, and which might have also impacted rapid growth in the revenue of test connectivity.
Okay, got it. Okay. A question from the audience is, what is the expected dip in 2023 for the revenue for the different test connectivity systems? So I'm assuming probe cards, sockets, DIBs. I mean, how negative is the year over year going to be?
It's definitely negative, and we have downgraded our forecast substantially since our last quarter forecast for the year 2023 for probe cards, sockets, DIB, equipment, IC, everything. And I would say it's substantially less. And for more details, I would really look out for TechInsights report, which we're releasing next month.
Okay. And any teasers as to where you think the overall market is going to be? Because obviously these follow the overall market. Has the numbers been crunched for semiconductors in general for 2023 yet? Or?
Yes, kind of. It's negative, maybe double-digit negative.
Ooh. Okay. But I know one of the things TechInsights tracks is lead time. So will the lead times improve when the growth goes down, or the lead times are going to still stay long for semiconductors in general, if you know? Since
unfortunately I do not have that data for 2023 yet.
Okay. And then just to clarify on the cost of test, you calculated it with both the ATE and the TCS in it.
Yes.
And historically, has it been calculated separately, or what?
That's a really good question. Yeah. We have two kinds of cost. One is the capital and one is the operative side. We take AT, handlers, and probers together. And then TCS, probe cards, sockets, and DIB together. They are two different sets. So we take the depreciation of AT and probers and handlers because they are capital equipment and it comes under capital expenditure. So we calculate the depreciation of that. And then we take the revenue total of probe cards, socket, and DIB, and not the depreciation, because these products come under direct operating expenses as they are test consumables. Then we add these two and divide the whole sum by the utilization or the yield. That's total number of IC units in our case, and that's how we get cost of test.
Good. Okay. Thank you for clarifying it. And a question that came in, is there a comparison of the cost of tests between IDM and OSAT? So do you, in your research, do you break down the markets by their end use?
End users. This is something we are looking to get into in the next term. We haven't been doing the researching more on the end user side. Yeah, this is something we will definitely look into.
Okay. Well, I thank you very much, Panchami, and certainly people should reach out to you if they want to know more about the markets in general and in specific for the different consumables and capital equipment. So thank you so much.
Thank you.
And want to thank our sponsors again. JDT Technology, Automation, and Intelligent Integrated Solutions. Smiths Interconnect, your global partner for innovative semiconductor solutions. And Teradyne, enabling the next generation of technology through advanced test solutions. Their sponsorship is what made this event possible and free of charge to everyone. So when you have an opportunity, please thank them for their support. And with this, I will wish everybody a great day and look forward to seeing everybody back here tomorrow at 9 a.m. China Standard Time. Thank you.